Here we go, we're all ready for another algebra lesson. We've been discussing radicals, and this lesson is going to go over the addition and subtraction of radical terms. Consider the following sum, 5 to the square root of 3 plus 4 to the square root of 3. Well, there's two terms in that expression. Each term has two factors, and the square root of 3 is a common factor. Square root of 3 is a common factor. 4 and 5 are other terms, or other factors. The square root of 3 is a common factor, so we're going to factor it out. When we factor it out, we're going to be left with 5 plus 4. And 5 plus 4 times the square root of 3 is 9 the square root of 3. So you can see that terms with like radicands can be added. Like radicals are added. Or subtracted. Okay? But unlike radicals cannot be added and subtracted. Okay? So if the radicand is the same, they can be added. Now here are two problems I want you to copy onto your paper for your first part of your homework. And I want you to do these two problems as part of your homework. 6 to the square root of 3 plus 4 to the square root of 3 minus 2 to the square root of 3 is the first one over here. Pause your video and do that one. The second one is 5 to the square root of 6 minus 5 to the square root of 2 plus 3 to the square root of 6. I want you to pause your video and do that on your homework paper. I'll read you off the answers. This one is 8 to the square root of 3. You need to show your work on those. And 8 to the square root of 6 minus 5 to the square root of 2. Now let's move on to something a little more challenging. 5 to the square root of 8 minus 6 to the square root of 2 plus 4 to the square root of 2. Can we simplify that? Think about it. Well, there's no like radicals. Those radicands are all different. Are they really different? Let's try simplifying them. You should notice that this and this have perfect squares in them. So let's take out those perfect squares. The square root of 8 is the square root of 4 times the square root of 2. The square root of 72 is the square root of 36 times the square root of 2. And 6 the square root of 2 cannot be simplified. Square root of 4 is 2, so we end up with 10 the square root of 2 there. 6 the square root of 2 stays. Square root of 36 is 6. We end up with 24 the square root of 2. Now, lo and behold, those are all like radicals, and we can add them. And we get 28 to the square root of 2. And that's the end of that one. I have another homework problem for you. I want you to copy this one on your paper. And I want you to do this as a homework assignment. So pause your video. And there is the answer, 10 times the square root of 5xy. Well, we haven't dealt with fractions yet. We add or subtract fractions. You should remember that you need a lowest common denominator. So what in the world are we going to do with this? Well, let's think about it. We can take that radical of a fraction and turn it to a fraction of radicals, right? Sure. Using the quotient property. So now we have 15 minus the square root of 3 over the square root of 5. Now, that looks a little better. What are we going to do next? You called it. Get rid of that square root of 5 by rationalizing the denominator. Multiplying by a form of 1, which is the square root of 5 over the square root of 5. We simplify that, and we're going to get the square root of 15 over 5. That looks a lot friendlier. Not friendly enough, though. We cannot subtract these because they do not have like denominators. So now we're going to take this term, the square root of 15, and give it a denominator of 5 by multiplying by a form of 1. And we're going to get 5 times the square root of 15 over 5 minus the square root of 15 over 5, which will, putting it over one denominator, be 5 to the square root of 15 minus the square root of 15 over 5. Can that be simplified any further? Yes, it can. This has it's really not a coefficient because it's not a variable term, but this is 5 to the square root of 15 minus 1 times the square root of 15, which is 4 to the square root of 15 over 5, and that is your final answer in simplest form. Now I have another homework problem for you. So you need to copy this, pause your video, and copy this onto your homework page. This is your third homework problem. Now, third or fourth, I lost count. While you pause it, I'm going to get to work on solving it. So copy this to your paper. Well, what are we going to do with this? Well, let's try getting rid of those radicals of fractions and put them into fractions of radicals instead and see if it looks any friendlier. 5 times the square root of 16 over the square root of 3 minus the square root of 9 over the square root of 2. Well, that looks a little better. I think it does anyhow. Well, this is going to equal, square root of 16 is 4. So we're going to get 5 times 4 over the square root of 3 minus 3 over the square root of 2. Well, that looks a whole lot better, but we certainly don't like radicals in our denominators. No way. So what are we going to do? Well, you're right. We're going to rationalize each one of these. So we have 20 over the square root of 3. And I'm going to multiply that by the square root of 3 over the square root of 3. And I'm going to take this one, which is the square root of 2. And I'm going to multiply that by the square root of 2 over the square root of 2. Just a note, remember when you write a radical, if this y is intended to be under the radical sign, the sign must extend all the way, or it is not technically under the radical sign. Same thing when you're writing a fraction under the radical. If you're writing this, do you really want that 2 under there? It better look like it's inside of it, and that is very vague. So please be careful that you use good proper notation. Okay, so let's get back to this. We've rationalized our denominators here. We have 20 the square root of 3 over 3 minus 3 the square root of 2 over 2. I hope you got this far on your own. We still can't subtract those because they don't have like denominators. So we have another step here. 20 the square root of 3 over 3 times 2 over 2 minus, I'm going to use my parentheses because parentheses are your friend, use them. 3 the square root of 2 over 2 times 3 over 3. Problem's getting kind of long, isn't it? That's okay, you'll have some longer ones for homework. And we get 40. 40 the square root of 3 over 6 minus 9 the square root of 2 over 6. And now we can write that over one denominator and do 40 the square root of 3 minus 9 the square root of 2 all over 6. And I don't believe there's a common factor there. So I hope that's what you got. If you didn't, we'll talk about it in video class. And that is the end of adding and subtracting lesson for today.